Students, today we are going to learn about single slit experiment. Okay, single slit diffraction. Simply, we have to say what is the aim of the experiment. The aim of the experiment is to determine the unknown wavelength of a given source. So, what is given the source? What is the given light? For that particular light, we are going to find out what is the wavelength. Okay, this is the apparatus spectrometer. So, we have here collimator and telescope and central table where we have to fix the single slit and either way diffraction grating means we will go. I'll show you that single slit experiment as well as diffraction grating also, how you are going to take out n slit experiment also. So similar thing, similar way, similar apparatus we are going to use that. Okay, so first you set the here the screws level you have to set. Is a very important level by using the spirit level, and set the focal length of your telescope as well as a collimator. Now I will take out first telescope focal length by using this screw. I'm going to open and close by seeing the longer objects by using this here eyepiece. Okay, so focal length means that object what is the opposite side clearly you have to see, then the focal length of your telescope is set. Now you have to set next one is a focal length of collimator you have to set. Okay, there we have to use here on the monochromatic sodium lamp I have used. Okay, here I will take out this stand used for the single slit or n slit we are going to place out, and we are seeing this by using the telescope. We will set the collimator focal length we are going to set. Okay, so by using that screw and we will move front back, and by using this telescope we will see from the collimator, so that light we will going to see. That means that single slit there you have adjustment you have to see that simple very thin line you have to get properly. Okay, by using that collimator, very thin line, not thick line you have to get. Where how much thick line you are going to take out, that much diffraction pattern you will not get proper thin lines. You thick when blur you are getting the pattern. That's why you have to set the collimator. It's very important. Okay, that light we have to see here in the form of very thin line. We will see here as at a time I will show you that single slit and n slits diffraction grating. In single slit pattern you will get three orders you will get. Why? Because we don't have here any monochromatic, we don't have any polychromatic, we have only monochromatic light. Okay, so we are placing single slit at center, and you will see, and you will get right side three orders diffraction orders, and left side three orders you will get here. Hmm. Now we are suppose we are going to place out here diffraction grating. Okay, so this is about single slit, three order left side and right side you will get here. In diffraction grating we are going to place out n slits. We will see for single order different colors we are getting. Why? Because you are going to use this polychromatic light. Poly means number of colors you have in that. Okay, now in the diffraction grating we will get only here first order. Some see that we have taken here the left side also, left side right side the colors we have taken, but don't go from the center to right side and then left side to center. Okay, so clear. You start from the yellow and I will going to end with here yellow. So then you are getting proper values you will get here. So otherwise the error you will get here. That you have to careful while you are going to take out n slit diffraction grating. Okay, diffraction grating means n slits we have. Clear. This is the way we are going to take out same experiment, same, but in place of single slit you have to replace with here. So n slits we have to replace. Now I'll show you here how to take out a reading by in single slit experiment. Now I placed here the cross lines of telescope. On the right side third line you will take out vernier 1, vernier 2. Now I'll consider this is the vernier 1 is the left side and vernier 2 is the right side. Vernier 1 is the left side and vernier 2 is the right. That's your choice which one is considering vernier 1 and which one is considering the vernier 2. I consider left side is the vernier 1. I have to take out the vernier 1 reading and vernier 2 reading. So third side, third right, third right, third order right side diffraction, right side diffraction pattern, vernier 1 reading and vernier 2 reading I have to take out. Okay, how you will take out vernier 1 reading? That is called main scale reading plus vernier scale reading into least count we have to take out. So similarly vernier 2 reading also you have to take out main scale reading plus vernier scale reading into least count. Vernier scale reading into least count, you have to take out in the bracket. First you have to multiply, then you have to add main scale reading. Okay, so I'll show you how to take out this vernier scale reading. Okay, so before that we will go for the least count. Least count is very important. That formula is 1 main scale division by total vernier scale division. You know this formula, and here at this operator, how you are going to find out the least count? That is a very important. No, for all the operators you have to find out first the least count value. So I'll show you that you will take out from the vernier 2 scale or vernier 1 scale, you take out anywhere, the least count is same. So see that on vernier scale there are 30 divisions you have, 0 to 30 you have divisions. Okay, that you are going to observe. And round scale, main scale, I'll try to focus here. So main scale, what is the gap between unit to unit? But I'm not getting that. I will come here, so I'll try to focus by using the light. Then you will get here 340, 350 and 0. What is the meaning of 360? Okay, 10 degrees gap you have between the unit to unit. How many lines you have completely? Small and big, totally 20 lines you have. Count down, 20 lines we have. Means for 10 degrees you have 20 lines you have. For 1 unit to 1 unit gap is 10 degrees. For 10 degrees completely how many lines you have? 20 lines you are going to observe here, 20 lines you are getting here. Okay, for I'll write it here, and I'll show you one main scale division value. Okay, for 20 lines, 20 lines, okay, small and big 20 lines, what is the value? 10 degrees is the value. Now what he is asking, one main scale division means one line to one line gap, how much? So one line value is how much? One line value is question mark, cross multiplication you do it, that you will get here 10 by 20 you will do it. So 0 0 cancel, 1 by 2, 1 by 2 means 0.5. So one main scale division value is 0.5 degrees. Okay, unit is very important. 0.5 degrees you will get here. So total vernier scale divisions. On vernier scale, I have shown you that 30 divisions are there. See that on the small scale. So small scale, how many divisions we have completely? 30 divisions you have. Very important that is. Now this 0.5 degrees I convert in the form of minutes. So this small scale I have to take out. So 1 degree is equal to 60 minutes. Half degree is 30 minutes. Half means 0.5 degrees is 30 minutes. Now can I write it here? So 0.5 degrees value is 30 minutes. 30 minutes by 30, 30, 30. I'm going to cancel out. 1 minute you will get here. Okay, 1 minute is the least count we calculated, and I'll place out here the vernier 1 and vernier 2. For all the values, the least count value is a 1 minute only. Okay, it will not going to change for these apparatus. So this is the way we are going to find out using the least count formula. So least count value is a 1 minute we calculated. Carefully you observe and you calculate similar way for the apparatus, but because for operators you will going to changes. Okay, so sometimes depending upon the company they are going to change the value of least count. Okay, now I'll place out here single slit. Imagine this is the third order what we got. Okay, for third order I am going to take out a reading, and I will show you that how you will get vernier 1 reading and vernier 2 reading. Okay, right, clear? So by using this same formula, vernier 1 is the main scale reading plus vernier scale reading into least count. Vernier 2 also same you have to take out. Now left side we consider as a vernier 1. So we will go and see that what is the main scale reading we have. The vernier scale 0 is the reference for the main scale reading. So where vernier scale 0 is coincident on the main scale means round scale. So main scale reading means you have to see on the main scale where 0 is going to exactly coincidence. Okay, exactly it going to match that value we have to say here the main scale reading. After 10, which line is exactly matching that value you have to consider as a main scale reading we have to consider. Now I'll show you on the paper. So what is the value you will get here? So this is 10 degree 10.35 degrees you will get. Okay, 10.35. I'll show you on that once again paper. So it is this is the 10th line. Okay, so small line, big line, small line, big line we have. So completely three big lines you have, correct or not? Three big line. So after that you have one small line. It going that vernier 0 is going to matching exactly, that will going to match. This is indicating so 3 5. Okay, three big lines, small lines we have. So that is called 3 5 10. That is I have written 10.35 degrees. So into least count is you already 1 minute. Now vernier scale reading, how you are going to take out? You know that 0 to 30 you have the vernier divisions. So exactly only one line is matching. That is very interesting. Only one line is matching with your main scale. That how you are going to see by using the magnified lens. You'll see in 0 to 30 which line is exactly matching. Okay, so the apparatus specialty is that one exactly it is going to match only one line. It is not going to match some difference you are getting. So here ninth line is matching. That's why I have written here ninth line. So now I write it here, the vernier 1 reading, total reading 10.35 degrees plus 9 into 1 means 9 minutes you will get. Unit is very important. Now you cannot add it degrees and minutes. So that's why I have written simply the value you write down in degrees and minutes. 10.35 degrees, 9 minutes you have the value. 10.35 degrees, 9 minutes is the value. So that is the way we are going to calculate it here, the vernier scale reading in minutes, degrees and minutes. Okay, very easy to calculate, correct or not? 10.35 degrees, 9 minutes is the vernier scale reading I have taken, left side reading I have taken. Similarly for the right side reading, we have to take out the similar formula we are going to use for the vernier 2 also. Main scale reading plus vernier scale reading into least count. How you will get here the vernier scale 1 reading, the similar way you will get here the right side vernier 2 reading also you will get here. Okay, so shall we go for vernier 2 reading, how you are going to take out? So we have taken on the spectrometer right side reading, we have considered as a vernier 2 reading. Okay, I will try to focus here and I will show you where vernier 0 is exactly matched on the main scale, that is called round scale, that is called main scale reading, that is called main scale reading, we will say that. Okay, clear this concept. Now I will go here and I am try to focusing, I will get here the main scale reading where the vernier 0 is exactly matching on the main scale, that is called main scale reading. Clear. Now we see properly and I will get here the value of the vernier 2 reading is 193.5 degrees plus least count already you know that 1 minute and we are searching for now vernier reading. So by using the magnified lens you will check out 0 to 30 which line is exactly matching with here main scale divisions, which line is only one line is matching with that main scale division, that one line value you can find out easily. Okay, one line value you can find out very easily, that is 7, you will get 7 into 1 minute. Okay, it's not degrees. Okay, 7 into 1 minute is 7 minutes, so cannot add it this thing, then I have written 193.5 degrees, 7 minutes we have to take out as a vernier 2 reading. You take out the difference between vernier 1 vernier 2, you will get here 180 degrees exactly. How sir? So this is your 0, okay, this is your 180 degrees and 270, so 270 and this is your 300. Okay, 270 and 300, correct or not? So vernier 1 is the left side you have, vernier 2 is the right side we have. So we subtract 180 minus 0 you will get here. So 180 only you will get, means right side vernier 2 reading and vernier 1 reading you subtract it, 193.535 10 degree 10.35 degrees, you subtract it nearly 180 degrees you will get here. Nearly how much value will get? 180 degrees value will get here. So that is the way we cross verify your values are correct or not. Similarly I will go for the second order vernier 1 vernier 2 reading, I will take out first order vernier 1 vernier 2. Similarly left side readings, first order vernier 1 vernier 2, second order vernier 1 vernier 2, left side third are also vernier 1 vernier 2 readings I have to take out. Clear this concept. Now this is a way I calculated here first only and I placed in the table and I will show you that how we calculated from the third order right side to third order left side you have to take out. That is very important. Don't go from center to right third order and center to left third order. The error you will get here. Now subtracting third order vernier 1 to left side vernier 2 you will get 2 theta. Similarly vernier 2 to vernier 2. See that I have taken the reading already. The vernier 1, vernier 2, vernier 1, vernier 2 for all the three orders I have taken that. Subtract vernier 1, vernier 1 reading, you will get 2 theta value. Similarly, vernier 2 reading you have to get 2 theta values you will get here. Now vernier 1, vernier 2 is subtracting 180 degrees you have to get, 180 degrees, 180 degrees you have to get, then its value is correct. Okay, see that 180, 180, 180 you have to get here that. Now what we have to do, subtract vernier 1 of left to vernier 1 of right side. Similarly vernier 2 of left side to vernier 2 of right side you have to subtract, then you will get here 2 theta value. Clear or not? That is the way you will get. But left left and right side are in the same range you have to get here. Same range. See 300, 300 you will get same range, and you have to get here 180, 180 range you have to get here. So there is a value 140, 140 we got here. So same range you have to get, otherwise how much you have to add, that is a very important. You have to add it, the subtract, you will not get here 2 theta value is a bigger value you have to get, very small value you have to get here that. So what we have taken the value, see that one value in the range of here 10 degrees 35, another range you have to get here 180 range you will get. Then at this condition what we have to do, you have to add 180. So then these are also converted in the form of 190 range. So then what you are getting subtraction, what you are getting is very small value you will get. Similarly other values you will check out. One is 360, another one is some 10 degrees you will get, then you have to add 360. Both are in the range of 360 you will get, then subtract it. That small thing you have to remember and take care about that values, small things, keep it, and you will get here 2 theta values, very small values you will get 2 theta values. Okay, now from 2 theta you observe vernier 1, vernier 2 readings you will get here. Now average these two values and you will get here 1 2 theta value. Okay, add these two and divide by 2 you will get here vernier vernier so 2 theta value you will get. From 2 theta you divide by theta, sorry, divide by 2 you will get here theta value. Okay, 2 theta value divided by 2 you will get theta value. Very easy way to you will get here theta values. That theta you have to substitute in the formula, lambda formula. Just now last column I have placed here. You will get what is the value in the range of angstroms you will get here. Okay, right, in the range of angstroms you will get here 5890 angstroms you will get here first order. Similarly for I will go for second order also in the same range you will get by using the readings, and similarly you will take out for the third and then third order also you will get same range you will get. If you are not getting, so do it number of times you will do it, but similar range you will get here. Average all these three, that's your choice, that's average all three and divide add 3 and divide by 3 you will get here one value that is in the range of 5890, means unknown wavelength of given source, very easy to find out by using the single slit experiment. Okay, clear? This is about the single slit experiment to find out the unknown wavelength lambda. Okay, so you take out here the single slit in result I have to place out in the manual. So in terms of angstrom is the unit, in centimeter you have, you convert in the form of angstroms you have to convert it. For the diffraction grating, similar operator, similar procedure you have to do, but in place of monochromatic we are using the polychromatic, that's why you are getting colors here. See that first column you have the only one first order I have taken, we will get here first order. So what is the colors available, I have taken for particular color we have taken left and right reading, means vernier 1 vernier 2 I have taken. Similarly how you have taken single slit, vernier 1 vernier 2 vernier 1 vernier 2 reading, and subtract vernier 1 of this yellow color to yellow color you will get 2 theta values. Similarly green color to green color vernier 1 2 theta values. From this theta value you take out and substitute in the formula, you will get lambda value. Similar way you have to do experiment. Thank you.